In this video, I'll be talking about sedimentary rocks, how they form, and also how they're classified. So here we have a beautiful picture of some sedimentary rock formations in Mount Zion National Park. And you can tell they're sedimentary rocks because they're layers of rocks, and you can see the distinct layers in the rock face. Okay, so we visited this picture with igneous rocks, and now we will start with sedimentary rocks. Sedimentary rocks, however, take place in all of these areas. Okay, so weathering and erosion are key. Weathering is breaking down. Erosion is transport. So pieces of rock, pieces of mountain are being broken down, transported, deposited, or dropped off. Sedimentation, so they clump together. And then we have compaction and cementation, so really sticking together. Cement, think cement. Compact, squeeze, and then cementation, cement. And then the process can start anew again. Or if it melts into magma, then it will turn into an igneous rock. Okay, so just again, going over sedimentary rocks. So forming from sediments, so it has to start as sediment. A sediment is something that must have been weathered and then eroded. Okay, and then it gets compacted, so it says settled sediment. Water and air get squeezed out of it, so all the sediments get pressed closely together and then cemented or glued together, and then we have a rock. So over here's another picture to show you weathering, and things that do weathering are stuff like water, gravity, wind, and some of those things also do erosion. So those are called agents of erosion that can break down and transport sediments around the Earth's surface. Okay, could go into water, could stay on land. Transport, see, and then deposition, deposited, burial, and compaction, so they're really going to compact together. And then you have a sedimentary rock after it's been squeezed and pressed together long enough. Okay, there are three main classes of sedimentary rocks. The first one is clastic. So these are made up of rock fragments, So they're made up of other pieces of rock. Chemical are things that evaporate or precipitate out of the water. And they're going to look like crystally. Oh my God, I spelled that all wrong. Okay, and then organic. Organic means contains carbon or from something that was once alive. Came from a live plant or animal at one time. So this can also be called bioplastic. And both of these types are also called non-clastic. There's a bunch of different names that we got going on here. All right, so again, clastic. Oh no, where's my pictures? Oh, there they are. Okay. Oh, very nice. All right, our clastic rocks made up of other pieces of rock. So you can see each of these rocks are made up of other pieces of rock. Some of the rocks are much larger, like this one here. That's conglomerate. It's made of rounded pebble-sized fragments. It's the easiest to pick out because it looks like a rock that's a bunch of little rocks glued together. Breccia over here, sharp angular fragments. So this rock is actually kind of smoother to the touch, but you can see that there are still large chunks of other rocks. We have sandstone. I didn't put a description because it's sand cemented together to make a stone. And that would be this right here, sandstone. And then our last one is shale. So that's made up of clay particles. And that's going to be the smoothest to the touch because clay is a very, very, very tiny particle. So it's going to be very smooth. All right, and our non-clastic chemical group, so we have dolostone, which is originally from limestone. We have rock salt, which can come in a variety of different colors. So that evaporates from ocean water. Now, if you remember, contains the mineral halite, tastes salty. Okay, and then rock gypsum is also an evaporite. So it evaporates out of water. And here is your gypsum. All very beautiful, and you can kind of see that they're also very crystally, so chemical crystally looking. All right, our next group is bioplastic, which is our organic, so from living things. So this first one, well, we'll start on the right. This is limestone. Oh, you heard my cats jumping around. Limestone, this is from marine organisms, usually ones that are shelled. Okay, so these are little bits and pieces of shells. Here where we live, you can probably find some limestone just if you go digging in your backyard, because we live in the coastal plain and we live right near water. All right, and then coal is another example of an organic sedimentary rock, but just the first 3 stages of coal development. So coal originally came from plant material. It's first called peat in its first stage of compression, compaction, and then over time, you can see here, more compaction, greater pressure, and then we get this lignite, so it's a soft brown coal, and then more, you see here, more layers are adding on top. So as things are coming on top, we're getting more pressure, more compaction, so our coal is continuing to change. And then actually, if we get more and more, it turns into a metamorphic rock down there. And this is another picture. It's a little bit bigger, so it's easier to read. It shows you coal formation, so ancient forests. So a lot of the coal that we have here today came from ancient forests. All those plants died, and then they were buried, and then things were pressed on top of them. And here, right here, this is your coal seam. So that's where the coal was forming, and you can see you have the pressure here and pressure from here. And then further compression will continue to alter the coal. And then anthracite that's the stuff that we really like to burn, but that is also the metamorphic rock. Okay, a sedimentary rock scheme. So you should be somewhat familiar with these from the igneous rocks, but I will kind of give you a brief overview. Again, always look at your axes. So running down here, we have texture. And then up at the top, we have grain size, composition, comments, rock name, map symbol. So if you saw it on a map, that's what it would look like. So texture, that's important. Clastic, and then see here, this is called crystalline, or we can call it chemical. Like I said, lots of different names. And then bioplastic, those are going to be your organic ones. Oops, hold on. Okay, so your clastic rocks are up here. We went over these. We did not go over siltstone. Grain size tells you relative grain size. Okay, composition, this just general because it can consist of a variety of different rocks. And then down here, composition tells you specific names of minerals. It's more specific with the non-clastic rocks. Okay, so you will be using that in the virtual lab, and please, please, please reach out if you have any questions.